Hello and welcome everyone. We're gonna get started in a minute or so. Give some of our attendees to join us. So we'll be starting in a minute or so. In the meantime, for those who have joined, please feel free to ask questions in the Q&A section. So there's a button with a little question mark where you can start asking questions. And then feel free to just ask ahead, like particular topics, particular areas that you might be interested that we can cover. And also, when we get to the lab section, make sure that you read the Q&A section, the chat section, because we have a link that you will need to click and get set up in your lab environment. All right, so we're gonna go ahead and get started, and I'm gonna do some introduction slides, and then some introductory concepts about Azure Synapse and some of the other technologies and business cases for this topic today, which is analytics in a day, and how cloud analytics can provide the business value and solve a lot of the common challenges that we see today regarding data. So we're gonna start recording this presentation. So if for some reason you cannot be recorded or don't want to be recorded, you may need to jump off. But we're gonna be recording this, and then we're gonna be making this presentation, this workshop available on demand through our website, and make sure that we'll make sure that you get that link. So with that said, welcome to Analytics in a Day. We're excited to show you how analytics can transform your business, and more importantly, what concepts you must understand to do more with data. And with that said, I'm going to do a quick introduction myself. So my name is Jose Chinchilla. I'm the Director of Data Analytics at Agile Thought. And I've authored or co-authored several books, including the exam reference book for the exam 70-767, Implementing a SQL Data Warehouse. And there's going to be some updated material around that and books that I might be working in the future, specifically about Synapse. So keep an eye on that. In addition to that, I am a MCSE, MCSA, and also I hold a Microsoft Certified Trainer certification. And I'm happy to share some of the content and walk you through some of the labs that we're going to cover today, and that you're going to actually have the ability to get some hands-on experience. So today we're going to talk about, how can we harness the power of data analytics, and how can we improve the experience of our developers, our knowledge workers, data professionals, to be able to make use of the data with tools that facilitate the analytics, the discovery, and deriving some insights, and be able to essentially enable a true data-driven culture in your business. Like I mentioned, later on in the workshop, I'll be walking you through a hands-on training. So you're gonna have access to a portal in an environment where you can actually be doing some work with Synapse and experience that. And then we're gonna have some Q&A questions if you may have. We can talk through them, or we can have some follow-up conversations. I'll make available throughout the presentation today a link where you can schedule some time one-on-one with me, just to understand some of your business needs, some of your challenges, and how can technologies like Synapse help with that. In addition to that, I wanted to bring up to your attention the Accelerate Summit that we delivered last week, and now all of the recordings are available on our website at azure.com, and you can look at the events and on-demand webinars, and you can see all the sessions there, particularly the 3 must-knows when implementing artificial intelligence. That is a panel that I facilitated, and we had great conversations that I'm sure you're going to find useful for your organization. So with that said, let's first start talking about some of the current situations and state of analytics today. We at Azure believe that all businesses are essentially data businesses, but this means many different things for different organizations. So today we're gonna take a minute to talk about what can analytics do for your business? How can the cloud, specifically Azure cloud platform, can enable better insights? And some of the inherent tensions, conflicts between the traditional approach to analytics and what are the solutions that Microsoft and Azure platform are bringing to the table to facilitate those challenges. And then we're going to talk what the ideal end state for analytics looks like. We'll build on this idea through the presentation. So this is going to be a little bit of covering some of the history in the background, where we are, and what are the new initiatives in this area. And then we're going to actually see it in person, right? How does that work? So let's first start with this, right? Today, all businesses are data businesses. And as you may already heard, data is the new currency. Data is the new oil, the new gold. So many references to the value of data. And data is at the heart of every modern business. Over the years, we've seen a massive digital transformation occurring across all different industries and regions around the world, right? We know with the pandemic and all of the turmoil within 2020, we've seen a lot of organizations accelerate that digital transformation and really adopt the cloud and adopt remote work and adopt all this collaborative tooling to facilitate that digital transformation. But that doesn't come, quite easily, right? There's some struggles and there's some success around that, but it is not very easy for organizations to be able to adapt efficiently to a lot of these disruptions. Now, that same element lies at the heart of the digital transformation, and it's also the underpinning of organizations that have proven more resilient during these turbulent times. And that underpinning is essentially the data, right? Everybody that comes together wants to collaborate and generate and analyze data. And data is what really enables the analytical power for these organizations and these collaborative groups to be able to analyze the past and be able to gain new insights and have the predictive power for future and the planning that needs to happen. So from that cornerstone with some of the online accounting, stock keeping, inventory management, all the way to the largest internet retailers, we see that every organization runs on data, right? You look at organizations like Amazon, they use a lot of data. They leverage a lot of the data that the customer, from their customer interactions provide, and they leverage that a lot, as well as many other retailers, either online or brick and mortar. But so those that manage, govern, and secure data effectively will definitely thrive in the new economy. So that's why data is really important, right? As you may already know. But of course, it is easy to gather and manage the data, to have all that governance around data. But it is a different story when you need to make decisions based on that data, right? This is where a lot of organizations struggle. We see it a lot with our customers, where they have internal strategies, internal initiatives, And they get so far and they get to a point where they're really struggling to find the value or expand the value of their data initiatives. And this is where the analytics strategy comes in. As we know, dashboards and reports help support the awareness of the current state of the business, business intelligence, data analytics, and all the nice visualizations with tools like Power BI, Tableau, MicroStrategy, and many other reporting platforms really strengthen the role of the knowledge workers with that informed insight. And then advanced tooling that augment our intelligence can really discover some of that information, some of those patterns that sometimes even experts or SMEs, right, or often overlook. As may be the case in your organization, there's just not enough eyes in front of a computer to be able to parse through the tons and tons of data that we are collecting every day now. And this is where tooling like Azure Synapse, as you will find out, really, really accelerates that time to insights. Now, while analytics is important, it's increasingly evident that not all data analytics initiatives are equal. Data science takes analytics to that next level because it enables automated insight with depth and scale beyond the abilities of human analysis, right? Allowing business to really understand their data better, faster, more efficiently than ever before. With patterns like machine learning or artificial intelligence, you can really drive autonomous processing and decisions, and organizations can respond intelligently. So there's a specialized field around autonomous processes and business process discovery, like RPA, robotic process automation, that can really, really help that. And with advanced machine learning, artificial intelligence algorithms, they can really see those patterns and automate decisions that need to be taken from specific events or specific states of the data. But in order to fully achieve that automation and depth of what's possible in data analytics, businesses really need scalable solutions that won't get them stuck in the data center business, right? And this is just happens to be the case of a conversation with a client where they have so much growth in terms of business, revenue, but an explosion in the data that growth is generating, that they are having a hard time to anticipate, what type of hardware they need, how much storage, how much processing power, and the fact that typically organizations don't have a budget that's readily available to say, yep, let's buy 10 more servers, right? Or 10 terabytes of additional storage, because that implies a lot of capital expenses and investment upfront, in addition to configuration and maintenance support of all that hardware. So these were cloud analytics, or what we call the modern cloud analytics comes into play, right? This is where a lot of organizations, a lot of our customers are finding the real value and be able to scale those analytic initiatives. And the great news about the cloud is that you don't have to make a huge upfront capital investment. You can turn on, turn off services as needed, and but the most important thing, that it allows you to scale up whenever there's a growth, is a need to support that growth in data, but also the ability to scale down when there's some, slow times, right? Particularly like we saw in 2020 with the pandemic, a lot of that business, those transactions really came to a halt for a lot of organizations. So instead of having all these hardware sitting in data centers, the cloud will have allowed a lot of those clients to, scale down their infrastructure, save on infrastructure costs. But in general, organizations that have adopted a cloud native approach are really seeing those benefits in terms of the collaboration, file sharing, and be able to scale as they need. Now, one of the great benefits about cloud-based analytic platforms is that it really eliminates, like I mentioned, that need for large capital expenditure investments, right? Deploying to the cloud is faster, it's easier. It's essentially a click of a button, and you have pretty much a platform ready to go within minutes or hours. And it allows you to iterate on different design, different architectures, and being able to deliver capabilities to handle diverse set of data more efficiently than you would do it on premises. So everybody has heard about big data and unstructured data, relational, semi-relational data, file-based data, and all of these in the past for on-premises type of solutions, you have to have specific tooling, specific skill sets for that. Now with the cloud, you are able to handle all this diversity in data formats and data types much more efficiently. And added to the value of being able to scale as the growth of data requires. And like I mentioned, not only scale up, be able to scale out, and most importantly, what a lot of organizations miss is the ability to scale down, right? Which is a big value added. So as the volume of and variety of the data expands, a lot of the modern cloud-based data services serve as a home for all that data. And with services and resources like Azure Blob Storage or Azure Data Lake Generation 2 storage, it really allows you to be very flexible on the type of data that you can ingest, right? You're not only constrained to, relational type of data, or you can pretty much consolidate all of those data sets in a single place. And you can also support varying types of workloads from, large enterprise models to, workgroup type of BI solutions, sandboxes, all the way to more advanced, predictions or predictive modeling that can be also combined in a single place. And it also can handle, the cloud can also handle very efficiently different processing schedules. So, ranging from enterprise ETLs or self-service discovery type of workloads, without the need to someone manually, configure and juggle through them, right? This is one of the greatest benefits I see with tooling like Azure Data Factory and some of the integration with Azure Synapse, where you can have, varying schedules and centralize that scheduling in a single place as well. And it also allows you to deliver, enterprise reports, enterprise dashboarding, as well as ad hoc data discovery through a variety of visualizations and data science tools. Now, with all this said, there's a paradox in analytics that has been happening for the last decade or a couple of decades or so. And what you probably have heard is that there's a lot of choices and endless capabilities of analytics in the cloud. And you're right about that. You have heard it correctly. You're not alone, and you're not wrong. Everybody, even us, especially us, which are in the consulting side, professional services side, we see a lot of new technologies, a lot of new platforms, a lot of new initiatives, and it really is evolving at a very rapid pace. And we're at a point to where it's really hard to keep up with all these different choices, capabilities, and really be able to know everything that's out there. So we share that same challenge, as you may also be going through. And we're at a point where there's a recognition of a paradox in analytics, which I'm going to talk about in a few minutes. So for example, right, we see an ever-growing volume of data. There's a lot of predictions in terms of the explosion of data that's expected between 2020, 2021 to all the way to 2025. And we see that, data will quadruple, if not more, right? And also we need to recognize that even though we're quadrupling the volume of data, the rate that across the industry that has been observed in terms of what percentage of that data can actually be analyzed. And the industry standard from a bunch of surveys and studies puts that at about 27%, less than 30%, right? That can be actually analyzed. So that's why we need additional tooling, additional approach to be able to analyze that data and get insights out of that data. So the problem isn't that the data itself is not, misunderstood, or there's not enough understanding of the data, but it's really the fact that a lot of that data is simply ignored, right? Organizations don't have the capabilities to analyze all that data. So what a lot of organizations choose to do is, prioritize what data, what type of data analysis they apply to their data sets. And a lot of that information is simply ignored, right? Because just they don't have the capability to do that. So when we talk with Fortune 1000 leaders and organizations, they tell us that although data analytics and AI are the top of their investment, top of mind, and they have data initiatives in these areas, but the feedback that we get is that it can be prohibitively challenging to be able to analyze all of the data. From this statistic that you see on the slides, you can see that 80% of those Fortune 1000 organizations struggle to advance their data insights. More than half of those blame those challenges due to data silos and also management issues as part of the roadblocks, right? How do you manage and govern all of that data? And furthermore, about half of them admit that they don't treat data as a true business asset. Not because they don't believe it matters, but really it's because they just don't have the processing capability, the skill sets, the manpower to get them there, right? So part of that underlying problem has to do with how the industry as a whole has approached data analytics up to now. Like I mentioned, for many decades, there has been specialized technologies and approaches to handling data, like data warehouses, data lakes, but those attack or those address specific types of data, specific use cases of data. And nowadays we see that there's so many different use cases and so many types of data that those approaches are having a hard time to keep up, right? There's not a single approach now. Sometimes organizations have a data warehouse, a data lake, ODS, data marts, to be able to cover all these different use cases. And with that approach, it creates a lot of governance issues, a lot of data quality issues, and one of the biggest issues that we've seen or we heard from our clients is just the duplication of data as well as the silo of data. Right? So not only we have silo data, but now in order to integrate that data, we have to duplicate that data in different shapes and formats, which brings another issue, which is the ETL, the integration part, right? There's a lot of heavy lifting around that I'm going to talk about in the next couple of slides. So all this creates, niches of data or silos of data, and not only silos of data, but also silos of technology and silos of skill sets. And this has led to ultimately this new paradox of analytics. The more we apply new technologies, new approaches, new methodologies to data analytics, the more technology we apply, the more silos we create, right? So it's a ever compounding problem where you have a new approach, new technologies, and that by itself, that approach by itself, creates silos. So the idea here is that to be able to harness the power of data, we really need to break down those silos without creating new ones, and we need to approach data analytics holistically. And this is where we're going to talk about the new paradox of analytics. So on top of some these data warehouses or data lakes, organizations still need more technology for visualization, reporting, data science, governance, management, etc. Each new technology that you adopt, like we mentioned, creates another silo type of operation, siloed process. The task of connecting all these different siloed systems now requires an additional set of specialized skills, building out new procedures, new protocols, and duplicating data, which, like I mentioned, essentially creates yet another wall, another challenge to get to that data set. When you step back a little bit and consider the traditional approach to analytics, building a new system for each of these new use cases or approach to analyze data, makes sense at the time because we were in that maturity level where we were just learning how to get most value of our data, and we just applied the technology that made more sense at that time. But as we added more use cases and more different technologies, we started creating all these silos. But as the volume of the data and the complexity of the systems themselves continue to increase, adding more and more technology has only compounded this problem, right? So there comes to a point where the complexity of adding new technology, new analytical approaches, processes, really outweighs the benefits of the technology itself. And this is where the new paradox, what Microsoft and ourselves were calling the analytics continuum, really needs to approach this as a holistic, in a holistic way, to be able to unlock the value of the data and really simplify and make data accessible throughout the organization with the correct or appropriate governance around it. So today it's very common that decision makers, really reach beyond, want to reach beyond traditional reports and dashboards, and really want to be able to derive better insights from new sources and utilizing new tools, right? Like big data, machine learning, or even artificial intelligence. However, the more advanced the technology, the more siloed the data, the more specialized skill sets that are required, the harder it can be to really understand what directly impacts the business, and what is the causal factors of the larger picture in the business. And that's why Microsoft took this new approach to analytics in Azure and really enable a more holistic experience of business insights. So Microsoft, through the Azure Synapse Analytics offering, re-architected the operational and analytics data stores to be able to take advantage of the new cloud-native architecture. This fundamental shift really maintains that consistency of tooling and languages, and it's really what has enabled a lot of organizations, as you will learn in the next couple of slides, to break down those silos of data and be able to make sure that the current skill sets, the current knowledge that their team members have can be extended into this new continuum. So not only breaking down silos of data, but also breaking down silos of skills among the organization. So in this case, like I mentioned, That's where Microsoft came up with this holistic, unified solution called Azure Synapse Analytics. And what Azure Synapse Analytics is really a limitless analytics service that brings together data integration, enterprise data warehousing, big data analytics into a single service that offers, in a matched time to insights. With Azure Synapse, organizations can run the full gamut of analytic projects and put data to work much quicker and more efficiently, a lot more securely than before. In Azure Synapse, the great thing about Azure Synapse is that it combines a lot of the capabilities spanning from data engineering, data integration to machine learning, business intelligence, visualization into a single experience. There's really great examples that Microsoft has made available. Some success stories like Walgreens, Mintra, and Procter & Gamble that have already achieved tremendous success with Azure Synapse in global type of implementations. And these capabilities can be made available, with a click of a button now within Azure. And a lot of the features that were recently also announced in the Ignite event are essentially generally available across many regions that we will see in a minute. So just to recap and summarize a little bit, so up to now we've talked about the value of analytics, the role of the cloud in this new modern analytics approach, the paradox that many of us face today in environments trying to approach all these different data silos and tooling, and then the ideal state that really enables that fluid continuum of analytics for every user, for which Azure Synapse has been introduced. So now we're going to do a little bit deep dive into Azure Synapse, describe all the different components, how it works, and also give you some tips on how you can optimize your analytics, and then followed by a hands-on workshop that you're gonna have available. So with that said, let's take a quick 5-minute break, just to make sure that everybody has time to stretch a little bit, get some water, some coffee, and we will be back in 5 minutes or less. Thank you. All right. So let's continue on our presentation today. I just sent this link into the chat or Q&A section as well, so that if you have any questions or any follow-up that you want to do, I'm making my calendar available so that you can schedule, 30-minute conversation, anything that we can discuss further one-on-one. I'll be happy to jump on those calls. So with that said, let's talk a little bit more about Azure Synapse Analytics and what it brings to the table. What are the benefits of Azure Synapse? So, like I mentioned, Azure Synapse provides a unified experience that brings together all the data ingestion, big data analytics, and data warehousing into a single development experience. So instead of stitching together all these different services that you may already be using now in Azure, in the Microsoft Azure Cloud, and thus creating more siloed data or more silos of technology or silos of skill sets. Now Azure Synapse brings all this together into that unified experience, not only in terms of the development and the tooling, but also the data itself, so that everybody's working with the same data. Everybody knows where all the authoritative data, the raw data, staging data, process data resides, and that make sure that everybody has the right access, that and the data has the right governance, so that you don't have any data leakage or data sitting in unsecure places, etc. Right? And it really simplifies the monotonous but sometimes necessary chores, right, related to data, and that is the security, creating automated pipelines, assigning permissions, opening firewall ports, and so on, right? So in the past, all of this involved many IT groups and many different responsibilities that it really makes the process a lot more complex, a lot more tedious when you're just trying to get to the data. And this is where Azure Synapse brings all of this together and provides role-based access to be able to manage some of these settings, but most importantly, be able to provide access to the data to the right people. Right? So all of this, like I mentioned, is secured and managed in a new development environment called the Synapse Studio, and within the Microsoft Azure services that support Azure Synapse Analytics. It really simplifies analytics the way everybody has been wanting to, and really delivers on the promise of simplifying the development and the data experience, right? The data access experience. So creating an analytics service that unifies these siloed or divided worlds or responsibilities really defines what Azure Synapse is about, right? And provides a holistic approach to data analytics. So Microsoft set out to re-architect and create all this a new wave of query processing for modern workloads, such as SQL-based workloads or more advanced type of workloads or scalable type of workloads with Apache Spark. And what they found out is that customers really needed a cloud-native analytics services engine that converts big data with traditional data warehousing and be able to access the limitless scale for structured, unstructured, and semi-structured data workloads. So the result of all this initiative and all this feedback that Microsoft got resulted in the new cloud native distributed SQL engine that powers Azure Synapse. I'm going to talk a little bit about that. and with really deep native integration with Spark, SQL type of engines, and it's now enabling a level of collaboration among data professionals that previously was not possible. So given this huge range of functionality available now with Azure Synapse, it's really nice to have a choice about how you allocate and consume these resources as well. So today, Azure Synapse offers two types of resource models. One is the dedicated resource model, and the other one is a serverless resource model, which gives you a lot more flexibility and better budget control. If you need more predictable performance and cost, or you have a set budget, you can create dedicated SQL pools and to reserve that processing power and store that data in SQL tables. But you can also accommodate for unplanned or burst spike type of workloads. And you can use the always available serverless endpoint. So you can have a dedicated set of compute power for your typical workloads. But if you see unprecedented spike in the workloads, you can make use of the serverless capacity to really be able to scale on demand and then be able to scale down back to your normal workload and normal compute resources. So that's a really great advantage that I think it's a game changer with Synapse Analytics. Now, I'm going to dig a little bit deeper in some of the features and attributes of Azure Synapse and talk about how all of these come together holistically to really optimize the data analytics experience. So let's start with security, right? So how can we secure the data? How can we provide the right level of access? And how does this integrate with other security and governance type of tools within Azure? So as you can see in this list, one of the ways is by building data protection within the fabric of the Azure Synapse service. So security is built in, it's top of mind, it's part of the building blocks of Azure Synapse. It's not an afterthought or it's an add-on, right? It's built into Azure Synapse. And with Azure Synapse, you get a comprehensive approach to security, from access and authentication to real value added here, which is proactive threat detection and protection and compliance. And this is a really cool feature. As you may already know, Microsoft spends a lot of money in research in the area of data protection, threat detection, and has put all of this built-in within Azure. So this is a really cool built-in feature that a lot of other cloud platforms don't provide. And because this is built within Azure, it means that you always get the latest updates and features in the product in this type of functionality. Azure Synapse also provides a way to manage the virtual networks and all the network connectivity between the different data pools seamlessly and in a way that keeps you in compliance. In this way, your team doesn't have to have specialized network environments, specialized network configurations to set up the network, set up the Synapse Analytics product. And most importantly, it lessens the burden on your network team to have to maintain yet another, VNet, another set of subnets, firewalls, etc. All of this is built in within the Azure Synapse ecosystem, and a lot of this is actually maintained behind the scenes by the Azure Synapse. It also makes it possible to easily apply, like I mentioned, data governance policies and procedures through the native integration of a product that you may or may not be familiarized with called Azure Purview. And what Azure Purview does is with Synapse is that it automatically discovers and classifies data assets based on what you set up and provides end-to-end data lineage. So Azure Purview already comes built in with some data governance policies, some rules to make sure that you comply with some of the industry standards when as it applies to data protection, data masking, um, tokenization of data, etc. One great customer success story is from a company called Grab. And Grab was one of those early adopters of Azure Synapse, and Microsoft worked with them to make sure that they were able to accelerate the time to insight using Azure Synapse. And the biggest challenge that they had is that they required to dynamically do experimentation with the data and provide proof of values with their projects. But the situation was that they have a large volume of data, and they also had to take into consideration a lot of the governing policies and laws that they need to comply because they are globally distributed across 8 different countries. So data residency, data privacy was top of mind, especially from their European customer base. And they were able to achieve all the data governance compliance through Azure Synapse with a data warehouse that provided that centralized sourcing of truth and reporting without having to create a lot of siloed data, right? They were able to unify all these within Azure Synapse. So this is a great customer success story that I would encourage you to look into the website, because it really highlights how Azure Synapse, along with Azure Purview, can secure your data and be able to keep you in compliance with a lot of the data residency, the right to forget, sovereignty type of requirements in many of these different regions around the world. Now, this is all great. You can secure data, you can have it in a unified or centralized location, but how do you bring all this data together, right? How do you integrate data? And that has become, I think, the largest problem with a lot of our customers, and especially with the Fortune 1000 companies, right? They have so much data. They have different line of business application, different transactional, operational applications. How do you bring it all together, right? And typically this involves some type of ETL or ELT, or perhaps even some real-time pipelines. So with this in mind, Microsoft created a really compelling story around data integration, because Azure Synapse employs, like a hybrid approach to data integration. That really allows you to integrate all the different data sources using specialized tooling or tooling that's specialized for a particular type of data, a particular workload, a particular use case. Again, all of this built within Azure, the Azure Synapse service, rather than disparate tooling around the organization. And adding to this unification of tooling and capabilities is the choice and the audience around these tools. So, for example, typically in most organizations, they have ETL teams, that are proficient with SQL, SSIS, perhaps Data Factory or Informatica, some other tools that require a specialized skill set. But there's also a growing need for a self-service type of approach, allowing subject matter expert, business analysts, data analysts, to some of the frontline workers even, to be able to ingest some of this data and make it available to their colleagues, work group, or even back to the enterprise. And again, these are, with our customer, we have found very interesting cases where a lot of very critical business processes are run in Excel or in Access databases sitting on somebody's laptop or desktop, right? In an entire revenue stream depends on these Excel spreadsheets, like Access databases, and when we discover these kind of things, right, it really highlights the need for those enterprise level data integration and data type of tooling. But there's also a need for these frontline workers who know the data and work with the data every day to be able to surface this data and integrate it back into the enterprise. So for this reason, Microsoft made available a lot of low code, no code type of user experience to be able to create these data integrations, be able to schedule and automate this type of data integration using event-based triggers, or like I said, just scheduled basis, to be able to import and integrate this data into a unified area. So this low code, no code interface, as you may have already experienced, has a familiar Excel-like feel, right? And what you see on this screenshot is essentially what many of you might already be familiarized, and this is Power Query. So Power Query is a low-code, no-code, self-service type of data ingestion, shaping, transformation tool that is built in within Excel. And as you can see, it's very Excel-like, the same paradigm of fields or columns and rows, and ability to apply transformations to a column or to a row. And this is embedded in Excel, but it's also the same technology that's available in tools like Power BI, Azure Synapse mapping data flows, now called Power BI flows, and now it's also part of Azure Synapse. So now you have this story that Microsoft has painted with and really taken a lot of great adoption, because now you bring this Excel-like capability, and we gotta be honest. A lot of our subject matter experts, business analysts, data analysts, managers, they love to work in Excel. As a matter of fact, we've had a lot of projects where we do this enterprise type of deployments and solutions, and at the end of the day, they always bring the data down to Excel, which is not a bad thing. That is the tool that a lot of these knowledge workers feel comfortable working in. So we need to empower them. And these services, this tooling that Microsoft is making available, not only in Excel, but also in more advanced tooling like Power BI, Synapse, really allows those knowledge workers to be able to apply those skill sets in these more advanced and more unified experiences, right? So this is a really great thing. It's also available now in Azure Synapse. Now, with all these different sources coming together, you might think that data latency and timing of getting that data may create some latencies, right? Some challenges on getting to that data promptly. But that's not the case with Azure Synapse. Azure Synapse creates a hybrid data integration approach that happens really, really fast, and also enables more real-time or close to real-time analytics. There's a whole section about real-time that we're going to talk about. But for now, I just want to emphasize that data integration is what really makes it possible. And the average latency or overall latency that is seen across the Azure Synapse platform is less than the 90-second, less than a minute, at the 99th percentile of the different use cases and workloads so far. So now we're going to talk a little bit more about data warehousing and how Azure Synapse really empowers the analysis of data through traditional approaches like data warehouses with SQL type of workloads. So it used to be that using a data warehouse was an enterprise level decision, and it really took months and months, maybe years, to get it set up and running, and the payback or return on that investment usually was expressed in months or even years, and in some organizations, even decades. There's still organizations that started their data warehousing journey back in the late 80s or 90s, and they're still working through it because there's a lot of, I guess, like we mentioned before, explosion of volume of data, but also variety of data. And these traditional data warehousing approaches may not be the more adequate. So today, we see the need for a holistic approach to data warehousing and data lake formations. And we need to build fully managed elastic platforms in Azure, right? Which Azure Synapse provides with a ready-to-use solution for any size or level of business. So if you're starting small or just getting started, Azure Synapse and the Azure services allow you to grow along with your business needs. And it gives you all these different features that you need in a single tier, provides the elastic computing capabilities that can be optimized for different type of workloads, and be able to, at the end of the day, control your budget and your costs, right? So talking about control, Azure Synapse Studio provides that unified workspace for your data preparation, data management, data warehousing, big data, and AI type of workloads. This is a similar development experience that some of you may be aware or maybe familiar with Azure Synapse, Azure Data Factory. And it really allows you to do this web-based, visual code-free interface type of development that a lot of data engineers can really migrate their skills into, as well as some frontline workers, data analysts, business analysts. And the idea here is that data engineers, database administrators, data scientists can all come together in a unified development experience without having, specialized tools, specialized applications installed on their workstations. Everything is essentially available in the cloud through this web interface. So Synapse Studio is essentially that web native experience that ties everything together into a single location where everybody can do their tasks without having to create siloed technologies and siloed data repositories. So anyone can use it. It is very easy to manage, and it does deliver the level of performance your business needs, right? And the question is, really, can it really deliver the performance for all these really different use cases and business needs? So the short answer is yes. And the way Microsoft is proving this is by looking at some of the studies and benchmarks that organizations like GigaOM derived from the TPC-H and TPC-DS benchmarks. These are some standardized type of benchmarks that you can read a little bit more about. And what GigaOM did is they did field tests that revealed that Azure Synapse, which was formerly back in the days when they did these benchmark reports, it was called Azure SQL Data Warehouse. It was able to outperform other platforms like Amazon Redshift and some other tools out there. So it's a very interesting story, very interesting benchmark report that you can take a look at. There's the link for that, and we can drop it in the Q&A if you're interested. And then just a little bit more insight on these benchmarks. So there's a whole, study that is available about the engine that powers Azure Synapse behind the scenes and some of the SQL tools, which is called the Polaris Distributed SQL Engine. And there's also the link there where you can look at the complete study, and it's really an academic study and really highlights how this new Polaris engine really works and how fast it is compared to other tools and platforms. So one of the key benefits of Synapse is that it really allows you to scale in and scale out your workload, right? So we talk about being able to have that elasticity. And the way you can do this is by using a scale approach that not only allows for predictable cost and simplifying the way you allocate these resources, but with the scale in and scale out option, you can increase the compute power of your clusters, either in multiple clusters or higher compute resources within your cluster nodes, right? So a scale in or scale out type of approach. There's a great example again with a organization called ABN AMRO. And the story with them is that they had very old legacy systems that they needed to maintain with using Teradata. And they were up to renewals and upgrades, which were going to be really, really expensive and a lot of capital investments. And they were trying to provide similar functionality or better functionality, and at the same time, with other tooling, but at the same time provide cost savings. And this is a great customer success stories that you can also read on Microsoft website, because they were able to migrate out of outdated Teradata systems to Azure Synapse and be able to quickly deliver new capabilities, remove all these silos, and generate new value-added services for their customers. All of this while saving, I think it was about 70%, yeah, 70% savings from previous costs and projected costs. So this is a really compelling story in terms of cost savings with Azure Synapse. So far we talk about how to integrate data in, typically in most organizations, this is done through some type of batch processing, schedule or event-based processing. But what about those specialized worksets that require more real-time operational analytics? So for this, Azure Synapse created a new type of technology, which they're calling the HTAP. And HTAP stands for Hybrid Transactional Analytic Processing. And essentially what they're trying to accomplish here is to remove the current challenge of bringing operational data, transactional data into your analytics workspace without having to do a bunch of ETL, right, or ELT type of processes. And Azure Synapse, with the technology they call Azure Synapse Link, finally breaks down that barrier, that challenge that has long existed between operational, transactional systems and your analytical systems. So what Azure Synapse Link does is that it links your operational databases to your Synapse Analytics in Azure, and by providing the ability to essentially get immediate insights out of your business data. So in fact, in some implementations, as soon as a transaction is recorded in your operational database system, that transaction is available in a more columnar format in Azure Synapse in a matter of seconds or even sub-second type of experience, right? So, but this is not, something that you have to engineer with your database system. This is not something that you have to do a lot of heavy lifting to accomplish this. Microsoft has made this available literally through a click of a button, where you can, where it handles all this configuration, all these settings for you. So this eliminates the need for complex ETL pipelines and worrying about having to keep multiple copies of data in sync. This is really, really, again, one of these game-changing technologies that I think a lot of organizations will have a compelling story in adopting Azure Synapse. So just imagine that for all of us who have had to deal with data integration, having to deal with ETLs, having to to extract the data, load the data in staging, landing zones, having to then read that data again and perhaps apply some transformations, changes, format it, transform it so that it aligns with the schemas of our data warehouses. That's a really tedious process. Takes a lot of time and a lot of management, a lot of maintenance around those, right? So whenever a column changes, boom, all of our ETLs break. Now we have to go do some triage and fix that issue, rerun it. So it's a mess. Right? That's the least rewarding area of data analytics today, in my opinion. But so imagine now a paradox where that is no longer needed, right? Where you, as soon as a transaction lands in your operational database, that transaction, that record is made available in your Synapse Analytics environment without you having to do anything. So that is magical to me. So it's a great feature there. So currently, Azure Synapse Link is available in Cosmos DB right today, but and I have to check again the Microsoft Ignite announcements, but they already have in the roadmap enabling Azure Synapse Link with Azure SQL Database, Postgre, MySQL, MariaDB. So all of these different flavors and of relational and non-relational, semi-relational database systems will be available also for Azure Synapse Link. So right now it's Cosmos DB, but Azure SQL Database will be supported in the near future, and hopefully they probably they announced it last couple of days. If not, will be announced in the next couple of months. So be on the lookout for that. So now imagine that real-time insights capability of Synapse Link with tools like Power BI. Wouldn't that be cool to just not have to worry about ETLs, not have to worry about shaping, transforming your data so that you can surface that data with tools like Power BI. So that is now possible with Azure Synapse Link. And this technology, what they call the HTAP, right? Hybrid Transactional Analytical Processing. So how does this work, right? I'm gonna just go really quick to this. It really just is a press of a button in Azure, in your Azure Database service. And then there's a direct link to the data that's established between Azure Synapse Analytics and your relational database. And what happens is the operational data is then automatically and continuously made available to Azure Synapse in a more optimized columnar structure, similar to what you might be familiarized now with in SQL with like a covering index. So it has a very high performance format and structures that allow for fast read and fast churn of the data. Right? So the bottom line is that no complex ETL pipelines or additional database computing resources are required, which results in no performance impact on the source database and makes all this data be available, in real time. Azure Synapse, in talking about real time, Azure Synapse also support the streaming of data ingestion from sources like IoT devices and other telemetry, logging, diagnostic data that's being generated. The current benchmark is about, or baseline is about 720 gigs of telemetry data per hour coming into your streaming into your streams that can be used immediately, right? You can process 720 gigabytes per hour at the current baseline that they've created. And this really allows you to have, real-time access to insights about your business and business data, which previously you had to stage in some type of data lake and apply some transformations to it to be able to figure out what's happening, right? And the great thing about this is that these streaming data sets can be accessed and managed through a T-SQL-like type of language. As a matter of fact, it's T-SQL. Pretty much all the T-SQL standard apply to these streaming data sets. There's a great story with a customer called Techno Alpine. And what Techno Alpine does is they have snow generating machines and that for ski resorts. And what they do is they stream the telemetry that the data that these machines is generating, and stream this data into Azure Synapse Analytics. And they can gain insights of what's happening with the different machines that are producing snow real time. Combine that data with like weather data, weather patterns, and be able to adjust settings in those machines in real time. And that we're talking about over 30,000 snow producing machines and thousands of components within these machines, right? Across more than 400 clients worldwide. And they're able to get access to all this telemetry data, machine generated data within seconds or sub-seconds, and be able to adjust settings in these machines in real time. All right, so next we're going to talk about some of the capabilities with machine learning and that Azure Synapse allows. But before that, we're going to take another quick 5-minute break, and then we're going to dive a little bit deeper into machine learning. In the meantime, feel free to ask some questions, and we'll try to go over those right after we come from our break. So I'll see you or talk to you in a few minutes. All right, so we are back. So let me continue on this next section, which is going to talk about some of these capabilities in machine learning, artificial intelligence in these advanced workloads. So, so now that data engineers, data scientists can collaborate seamlessly in a unified experience, using some of these code-free or code-first experiences to train machine learning models in Synapse now can be powered along with other Azure services. Like Azure Machine Learning. And typically, they can either decide to work using like a SQL type of experience, or they can also use notebooks to collaborate and author these type of predictive models and machine learning models. So, whether you use some of the pre-built models that are available from Azure, and specifically at the Azure Machine Learning service, or either you decide to build your own models, you can automate all of these machine learning tasks with Azure Synapse in a matter of days or less than a day, in a minute, right? Where you can simply import a model and then run predictions within practically minutes, right? You don't have to work days to build up the infrastructure and all this framework. You can build it, you can integrate it right into the machine learning capabilities within Synapse along with Azure ML. Now, just talking a little bit more about this notebook development environment within Azure Synapse. You may be familiar with Jupyter notebooks, and this is essentially a flavor of what a Jupyter notebook is. And it allows you to do a code-first approach to model development and use essentially your favorite language, right? From PySpark, Scala, C, and even C#, which is not readily available in all of these notebook environments. You can bring all of these capabilities and skill sets and along with SQL, which is important, right? PySQL or Spark SQL, and be able to leverage the existing skill sets from your team members in your organization. One additional feature that I just want to point out real quick is that not only it allows the flexibility of choosing your own language, but it also allows you to take advantage of features like IntelliSense that allows you to make make short work of redundant, predictable coding. So, or if you're struggling or still in a learning path in some of these languages, IntelliSense is really great because it allows you to essentially autocomplete, right, the function and give you the format of how that function is to be constructed. So this is really powerful. Personally, in my journey to learn more Python and more PySpark, Scala, this has been really, really useful because instead of going out and searching tutorials or watching videos, I can really see what are the elements that I need to provide to make that function work, right? So really powerful IntelliSense within the notebook environment in Azure Synapse. But like I mentioned, notebooks aren't the only place that you have a choice to build your models. Synapse also supports the industry standards for data types and languages, as you can see in the slide here. So, you can use PySpark, Scala, C#, SQL, and also be able to work with or generate different type of data formats and data sources, including file-based formats like Parquet, org, CSV or comma separated values, JSON, but also some of that unstructured type of data sets like images and videos and documents that you can parse through using different libraries within like Python or Scala, for example. In addition to that, the Azure Synapse engine allows for what Microsoft calls automatic ML data exploration to really help you derive some of these the best predictive models, right, for the use case or objectives or business challenge. Right? Automatic ML, if you have not worked with it, is really, really great because you don't have to be a quote unquote data scientist to be able to leverage some of the pre-built machine learning models available through Azure ML. And it really allows you to quickly explore, what is the best, regression model? What is the best approach or algorithm that you should use to a specific outcome that you're looking for? Really, really great functionality. And I encourage you to experiment with that a little bit more. Now, again, the story here is that you don't have to go to Azure Machine Learning, the Azure Machine Learning service to be able to make use of those models. Now, all of this is integrated within Azure Synapse Studio. And as you can see in the slide here, you don't even have to write, a lot of code. You simply, click and a couple options, choose the model, and provide the data that these models require. And you can do all this from within Azure Synapse Studio. You don't need any formal training in, like I said, in data science or machine learning. Some familiarity, some good background, foundational knowledge might be needed. But other than that, if you want to do like a prediction of, how much you're going to sell of a particular product, you can leverage existing ML models with a click of a button. In addition to that, if you're into what's called ML scoring, it really helps, that integration really helps to choose the best model and provide the scoring of these models based on that business need. So all of these with code free, right? Point and click pretty much is the experience here. It also enables to nearly anyone in the organization to create and access very intelligent predictions, like I mentioned. You can integrate other third-party tools and vendors, like you see in the slide deck. Other specialized compute engines like Databricks or other platforms like SAS and Spark, other libraries and frameworks like PyTorch, TensorFlow, and many other ways to integrate all of these specialized tooling for doing all these predictions. There's another great example from Microsoft called Amerisource Virgin, and you can read a little bit more on what they were able to accomplish with Azure Synapse Analytics. But in essence, they wanted to democratize the analytics for everyone. They wanted to make sure that frontline workers, information workers that needed certain specific data sets have access to the data securely in a short period. And the challenge they have is that they needed to run a analytics-based decision support system, and they were able to do that without the need of, specialized data engineers at every step. Azure Synapse Analytics was able to provide a self-service platform that the company used to make better predictions and take better decisions from the data. So this is a very compelling customer success story that you should also look into for that self-service type of use case. In addition to that, not only you can integrate very easily with Azure ML, you can also bring reporting capabilities with Power BI. And as you can already understand from your own journey, and perhaps place yourself in this journey of trying to get hindsight from past experiences, trying to derive insights from what's happening now, to all the way to make predictions and have that foresight of what will happen or how can I change an outcome in the future. it's very difficult if the only thing you're looking at is data, right? Raw data. That's why you need more business intelligence capabilities, like using tooling like Power BI to really surface all that information in a way that allows you to not only do descriptive analytics and predictive analytics, but be able to do also prescriptive analytics to be able to influence that outcome. And all of that can be done within the Power BI and Azure Synapse integration, as well as the leveraging Azure machine learning models to make those predictions and prescriptions all in one development experience. And you're going to see that in the lab in a few minutes. One of the cool things is that if you already have Power BI or already in your journey to implement Power BI, you can easily leverage your existing Power BI data sets, reports, dashboards, and integrate them into Azure Synapse. So now information workers have one place to go. They don't have to go to the Power BI portal or your own reporting portal. They can do all of these and access all of these reports, data sets in the Azure Synapse environment. And I'll show you how that looks in the lab. So there is some great statistics that Microsoft has made available from their own research and studies and customer surveys and feedback, and they were able to determine what is that return on investment and what is that total cost of ownership of a solution that combines Azure Synapse with Power BI. And what they found is that in average, their customers saw a 250% return on investment, and they noticed a 26% lower total cost of ownership by having this combined, unified approach. So really compelling and really good stories out there. So in terms of a use case or a customer success story, there's one really great by Procter & Gamble. As you know, Procter & Gamble has produces, manufactures, and sells a lot of consumer goods, a lot of name brands, and they have the challenge that we're having is that they had over 500 million queries that churn through petabytes of data across different markets, across different regions, different products, and they wanted to make sure that they were able to deliver access to this data to their sales force and some decision makers across the company. And they were able to do this by combining Azure Synapse with Power BI to be able to understand, market conditions, market changes, customer needs, across a massive amount of data. So they're able to scale all these through Azure Synapse in combination with Power BI. In terms of availability, this is a little bit dated. It's back from January, but Azure Synapse is available in most regions, or pretty much all major regions. But every other quarter, Microsoft is adding Azure Synapse, or deploying Azure Synapse in more regions. In addition to the features, capabilities of Azure Synapse, you have the ability to integrate with other third-party solutions, third-party tools, technologies, and platforms. There's a large ecosystem that's growing every day that you can see at a glance here that Microsoft has already partnered to bring those capabilities within Azure Synapse. So before we pivot into the hands-on lab, I want to make you aware of the Knowledge Center, where you can find a lot of these samples and examples, that some of those that we're going to cover through the lab. You can actually deploy those right from your own subscription, from your own environment, and be able to accelerate your understanding and learning process. So Knowledge Center will allow you to use samples immediately, be able to browse the gallery of sample solutions, sample data sets, sample codes, and essentially tour Synapse Studio, right? And be able to do some prototyping and do some learning there. At the end of this lab, and probably towards the end of the day today or tomorrow, you will see a link that either will come from us or will come from Cloud Labs with the ability for you to deploy Azure Synapse for free in a test environment. And I think it's good up for 7 days after this workshop and available for like a full day, about 6 hours, I think it's the limit. So make sure you take advantage of that because you can expedite that learning and implementation. In addition to that, just wanted to make you aware that Microsoft has also made available accelerators that allow you to either port or integrate existing solutions along with Synapse. So their solutions between Synapse and Qlik be able to migrate or integrate with Qlik, along with other technologies like SAP, SAP HANA, for example, also Informatica. And there are some free offerings from Microsoft that allow you to do proof of concepts with specific technologies like Informatica, Qlik, and also be able to save on your migration implementation, migration journey. Now, a lot of these will expire soon. This particular offer, which allow you to reduce your costs up to 76%, if you migrate to Azure Synapse by May 31st, 2021. So essentially, in the next 2 months or so, you can realize a lot of savings by accelerating that migration. All right, so with that said, we're gonna jump into the hands-on lab. I think my amazing team member, Madison, will be posting or sending the link for you to register for the hands-on lab. So make sure that you click on that link and you activate your lab environment. Madison, I believe that's already was sent by email. So make sure that you click on that link, activate the lab. And once you do that, we're gonna come back and work on the labs. For now, what we're gonna do is we're actually gonna take a 10-minute break. Originally it was planning for a 15-minute, but it will be a 10-minute break. You know, grab a quick lunch, coffee, water, stretch a little bit, and then we're gonna come back and walk through the labs. So this will be really great for some of you that want to learn how to work with Azure Synapse. So with that said, let's take a 10-minute break and we're gonna come back to do the labs. All right. So hopefully everybody is back. I wanted to check any questions so far or anything that you need help with in terms of setting up the lab. If you have any issues, please feel free to add them to the Q&A section, and then we can address it if needed. So with that said, I'm gonna start. I'm gonna share my browser because now we're gonna work in the Azure Synapse environment. So let me get that working. All right, and let's see, am I sharing? Yeah, there we go. I need to add the content. All right, here we go. So I assume you can see my screen. And I want to make sure that, yep, I guess you can see my screen now. So what I want to do next is I'm going to walk through the lab environment. So in your email, you should see the instructions to connect to the environment. You should receive an email similar to, with the information similar to what we have here. And you should be able to access the lab from the link where it says Access Lab Now. And you should see the environment information, each one under the environment details, where you will see your username, password. That username, password that you will receive, you can do a couple things. If you have a laptop or desktop that has a lot of restrictions to it, then what you can do is you can enable the virtual machine that's available here. You will need to start it. Once you start the virtual machine, then you will be able to remote desktop into that virtual machine. And that will allow you to access the Azure portal with the username password that is provided under the environment details section. If you don't have a lot of restrictions or any issues with that, then you can do what I'm doing, which is just open Edge browser or Google Chrome and go to portal.azure.com. Once you go there, you will be asked for a username password, and that would be the Microsoft Azure Labs .microsoft.com email or username that you see there, and then the corresponding password that you have in your environment. Once you log in, you'll be able to go to resource groups and see that there's a Synapse AIAD dash a number, and that number corresponds to that number in your username. So because everybody will have their own environment, and you will see all the resources that have been deployed there. So before I continue, I want to check, are there any issues, or is everybody able to log into their cloud environment? If you have issues, please put it on the Q&A. Something that I do is I maximize this the lab environment details so I can have it available in its own window, and I'll walk through this lab and go through the different exercises here. So assuming that you have access to your lab environment, your Azure portal with all the resources, the first thing we want to do is we want to read a little bit about the lab that we're going to do today. Today we're going to be using data from a fictitious company that Microsoft created along with some sample data called Wide World Importers. And what Wide World Importers do is they essentially sell products to direct to customers and also to resellers. And what we're going to do today is we're going to analyze some of that data that Microsoft has made available for us. A lot of this data is already imported into our Azure Synapse blob storage and data lake storage. And we're going to be able to leverage that data within our Azure Synapse environments. Like again, you would see this environment details with your user and password that you will need to be able to log into your Azure portal. All right. So we're going to go to the next exercise, the first exercise, which is the exploring the data lake with Synapse. Right? And in this exercise, essentially, we're going to do a quick check of the environment and make sure that we have the resources turned on for that. We need to turn on the SQL pool. We're going to build a quick modern data house using Azure Synapse pipelines. And we're also going to do a exercise on how can we integrate Power BI with our Azure Synapse environment and look at some performance analysis with the SQL pools. And I'm going to walk you through that data science exercise. There's an issue with this lab, so I'm just going to walk you through this particular one, what the expected result is. So with that said, let's jump on the first exercise. So the first thing is explore the data lake with Azure Synapse, SQL On Demand, and Azure Synapse Spark. As I mentioned, once you log into your portal, you should be able to see the resources available. If you don't see them, just click on the resource groups and then click Synapse AIAD. And then you'll see all the resources in that resource group. The first thing we're going to do is, I'm going to bring this here, is we're going to navigate. Why is this taking time? Let's go back here. And we're going to go to our ASA workspace. But that will launch the Synapse Blade. But before we do that, we want to make sure that our SQL pool is on. So we're going to click on that resource. And if yours is paused, you should be able to see a button here to resume that SQL pool. So go ahead and click on that. And we're going to wait. You're going to have to wait a few minutes to that to turn on. I think there's a question here. Username and password. Okay. So how do you get your username and password? So you should have gotten an email asking you to activate your lab environment and to register. And if not, please reach out to us via email, and we're going to make sure you get that email. Once you activate your lab environment, you should see also an email with the instructions on how to get to your username password information. So in this case, you will go to the environment details and you will look at the username and password that's there. That one is mine, but you should get your own username and password in there. Okay, so once you log in, again, what you want to go to is to the resource group that has been created called Synapse-AIAD your own attendee ID. And then in there, we're going to turn on the SQL pool because by default it's turned off or paused. So we're going to resume it. Once it's resumed, the next thing to do is we're going to go to our Azure Synapse Analytics workspace. In this case, you will see it by using this icon, the Azure Synapse icon. So when I click on that, and once you click on that, you will see some of the properties and some of the configurations. Where you want to go is you want to open your Azure Synapse Studios from here. Let's see. I think there's another question. Give me 1 second. Yeah, so the question is about the username and password again. So when you activate your lab, you get an email to reach that environment information that has been created for you. So everyone has their own username and password. And once you click on that activation, on that email, you will see your username and password under the environment details tab. Hope that helps. So yeah, so once you log into your environment and turn on your SQL pool, the next thing is to open your Synapse Studio, and you open that by clicking on this open link right here. And what will happen is the Azure Synapse Analytics Studio workspace will open up and will allow you to follow these exercises. The first thing I want to point you to is on the left-hand side, you'll see a small arrow or double arrows, and you can expand that to see the descriptions of what these icons are about. So home will take you to this landing page, and it will give you some of the recent resources and some quick links to some of the functionality. The data tab or section will allow you to see all of the data artifacts that are available for you. In particular, we have a SQL pool database or set of tables, and a SQL on-demand set of tables and objects. If you go to the develop section, you will see that there are some pre-built SQL scripts, some notebooks, data flows, and a Power BI workspace that's connected to this Synapse Analytics. Under the integrate side, that's where you would see the integration with Azure Data Factory. And here you will see all the pipelines that are in the Synapse Studio. Monitor will allow you to, like the name implies, to monitor the different jobs, different pipeline runs that have been executed or are running if you had any running. And then under manage, this is where you'll be able to look at all the resources that have been configured with your Synapse environment. I wanted to point you to link services. This is where you integrate with things like Power BI, machine learning, Azure ML, and also under external connections, you'll be able to see the Azure Purview integration, which allows you to create that data discovery, exploration, registration of your data, and create masking and other data privacy, data tokenization or private masking activities. All right, so now that we are familiarized with our environment, we're going to follow our lab. And the first option there is, or the first step there is to look at the data that we have available. Particularly, we're going to look at the data under the SQL Pool 01, and then under the linked data set. So we have, I showed you in the workspace, the databases and the different tables and objects available for those databases. In addition to that, on the right-hand side, you see the linked data section. If you click under linked, the link tab, you'll see that we have data sitting on an Azure Blob storage and also on our Azure Data Lakes Generation 2 storage, and some data sets that are also created based on some of these data sets. So the first thing is we're going to navigate to our Azure Data Lake Gen 2 storage, and you can expand this a little bit here if you want to look at the entire label. And the first thing is we're going to expand our primary workspace. And we're going to navigate to our worldwide importers data set. Then we're going to navigate to our Parquet folder under 2012, quarter 1. and then into the first partition, which is the 2012-0101 folder partition. So in here, you'll be able to see a single parquet file that contains data for that date. In this case, is invoice data for the date of January 1st, 2012. Now that we have identified the particular file or files that we want to work with, we're going to right click on it and choose select new SQL script, select top 1000 rows. So what you will see happen is that it will create a new tab up here. So before we were in this tab, and when we right click selected top 1000, it opened a new tab. And that new tab essentially is a SQL development environment. You can hide, if you wanted, you can hide this by clicking on this icon right here. And this will give you a little bit more real estate. And you can also collapse this section by clicking on those double arrows here at the top. So straightforward UI, right? So now you have your SQL development experience, and this is, think of it as such as, you would be familiarized now with SQL Management Studio, right? So what it did is it automatically created a script that selects top 100 rows from an open row set data source that is pointing to a parquet file. As you can see, it's .parquet, but it also the format that's specified is parquet. So it already has these methods that allow you to read and parse parquet data. So now that we have that, we can select that or just run it, and it will initiate the execution process. So at the beginning, it's going to take a few seconds for it to completely read the data, but as you read it multiple times, it will cache that data and be able to read it a little bit faster. So if we run it again, that should take less than a second, or about a second, right? Where before it took about 9 seconds. So it's able to cache all this data as you read from it. And as you can see, just like in your SQL Management Studio experience, you'll be able to look at a preview of the data, in this case, top 100 rows, in a table or grid format. You can also choose to change that to a chart, right, and create quick visualizations by clicking the chart. And automatically it generates the best option to render or visualize that information, and you can tweak it here on the side. All right. So that is essentially a quick way to preview the data. And of course, we can, if you wanted to, instead of looking at the top 1000, we can do a count of rows. So let's do a count star. And we can see that 32,000 records are in that particular file. Now, the next step is, instead of looking at a particular file, what we can do is you can either copy this from your exercise, or from here, you will see that the folder structure or in this data lake follows a year, quarter, date partition. And in this particular exercise, we're specifying a particular file from a particular invoice date. In this case, let's replace that section with a star. And what would that allow us to do? Star, and then we need to also specify the next folder, which correspond to files within that subfolder. And what will this allow us to do is essentially read from this data lake store, from this particular folder, subfolder, right? So WWI, FactSale Parquet folder, and then look at the data within the 2012 folder, Q1 folder. By specifying that level, we're specifying all dates within the Q1 folder or all subfolders within Q1, and then all files within those subfolders under Q1, right? So this is just saying essentially bring everything for Q1 2012. And we're gonna do just a count, just like we did on the other exercise. We can highlight so that only executes that portion of the code, and then we click on run. Again, it is iterating through all of those files in this folder path, and is reading the data and then applying the counts. As you can see, the first time it took 8 seconds, and it read 299,000. 2.9 million rows, right? 2,981,716 rows. And it did that the first time in 8 seconds because it's the first time it has to read and iterate through all the files. Let's run it again. And you will see that the execution time will be much shorter because it should, so should about 3 seconds, I guess, 6 seconds. So every time you run and you read new data, it automatically caches this data and automatically allows you to analyze this data faster, right? Each time that you interact with the data. All right. So the next exercise will allow us to define more complex queries. So we're going to go back to the develop section. And under develop, we will see a exercise 1 script that's already built for us. So if you click on it, it should open a new tab up here. And we want to make sure that we change the resource to be SQL Pool 01. This should be the built-in. And under built-in, we should see the SQL on Demand 01 database. So it's important that you change these settings to be built-in and to use the database, the SQL on Demand 01. That database that we're referencing here is essentially, if you go back to data, it's essentially this database under the workspace called SQL on Demand 01. And then you can see the external tables that in views should be there. All right. So once you open that script, exercise 1, read with SQL on Demand, and open that script, you should be able to run it. And it's a similar query, right, where we're counting records from this folder path. The difference here is that we're no longer reading from Parquet files, but we're reading from CSV files, right? So while that's running, if you go back to data, you'll see under linked that there's 2 data stores we have. We have a Azure Blob and an Azure Data Lake Gen 2. And then for WWI, we have 2 folders, one containing the data in Parquet format and the other in CSV format. So in the first query we did was against the Parquet file. The second query is against the CSV file. So I just wanted to point that out. All right. So this executed in about 38 seconds. Now, something that I want to point out, the differences between these 2 scripts is in this script, for example, we only specified the path. We didn't have to specify any type of format, right? So again, if we do like this one, if we revert this one back to top 100 and read it again, you see that we have column names where we're expecting them. And also, it knows the additional metadata like data types, because Parquet allows you to not only save the data in files, but it also allows you to save the corresponding metadata for each of the columns. And Parquet is a very popular file format for data scientists and big data engineers, because it allows you to store data and metadata, and also be able to compress it in a small file. And you can know that it is compressed because it has this additional section here in the name called Snappy. And Snappy is a type of compression algorithm that is being applied to the Parquet file. It doesn't matter what compression algorithm, as long as it's like a zip type of compression. The Parquet method for reading this data knows how to, uncompress it and read it, right? So, so that's the benefit of using Parquet. Now, in the other exercise, we're not using the Parquet version, we're using the CSV version, as you can see from the path, and we can see from the format. But as you can see, the script is a little bit longer, right, than the other one. Why? The reason is because not only we need to specify the path and what format, we also need to specify what is the field terminator, or if it's separated by commas, or separated by pipes, if it's separated by tabs, whatever that field terminator is, how it is if there's any field quotations, and where does the row data starts. In this case, we're saying that the first row of data starts in line 2 or row 2, right? Because the first row or the first line has the actual header names. In addition to that, we need to specify what are the different column names and data types, right? And then be able to return the data. We can also do like a select top 100 star, and we can run this, and you can see that what's it gonna? Oh, because there's a so this version of data and scripts have gone through multiple iterations, and I think they haven't updated the metadata, and I believe is let's do 16.2. I think this is the issue. Yeah, so the actual values on those columns are exceed the metadata that was originally described here. So you might need to increase that, or the precision and the number of digits. So you can see that now that we have defined that it's a CSV and defined the corresponding header, our field names in data types, now we're also able to see that data, right? So that's a very simple, very similar experience as you might be already familiarized using SQL Server, MySQL, using a development environment like SQL Server Management Studio or some other querying application. So the next thing is, so we can close these two tabs. Actually, we can close all these tabs. The next thing we're going to do is we're going to go back to our linked tab. So if you don't have this open, you can expand it by clicking on these double arrows, and you can expand the data lake Gen 2. And under WWI, what we want to do is we want to go back to that partition of, in this case, the fact sale Parquet 2012, Q1, invoice date of January 1st, 2012. And we're going to right click on that Parquet file, but instead of selecting new SQL script, we're going to select new notebook. And we're going to select specifically the load to data frame. So for those of you who are familiarized with Python, Pandas, PySpark, you might be familiarized with this concept of a data frame, and I'll explain that in a little bit. If you get this error like the one I'm getting, you need to make sure that you attach this notebook to a Spark pool, in this case, Spark pool 01. Sorry, and that you make sure that you are using a Python PySpark type of notebook. So once you specify that, okay. Once you specify that, you will see that now you'll be able to run this cell. And what this is doing is this is specifying that this is a PySpark command or function. And that what we're doing here is we are assigning to a data frame called df this data that is contained in this file and in this format. So essentially returning the rows within that Parquet file to an in-memory object called a data frame. And in particularly, that we're defining the name of that data frame to be df. And this could be whatever. You can call it df1, you know, my df, or whatever it is. It doesn't have to be df, right? In this case, we're just going to leave it as df. Now that then we assign those rows or that data from that file into this df data frame, now we're going to use a command called display. And we're going to display the df data frame. And we're going to limit the number of rows being displayed by 10. Only the first 10 rows, right? In order to execute this cell, so this is a cell. In order to execute this cell, what we need to do is you can decide to click here, run cells, or you can do a Control Enter or Shift Enter. And when you press Control Enter or Shift Enter, it will execute all the contents of that cell in order, right? It will note that it needs to execute a PySpark command, load the data into a data frame, and then display the top 10 records. The first time that you open up a notebook or run a notebook, it will take a couple minutes. And that is because it's generating a new Spark session with in the Spark pool cluster that you define. So the first time it's a little bit slow. So just going to give it a couple of minutes for it to initiate the session, read the data, and display it. So in the meantime, let me take a look at see if there are any questions. All right. I think there's none. Oh, there's a couple of few questions. Did I miss it? Did I miss them? Let's see. So I've logged into the lab and I'm not seeing what you're displaying. Okay. So if you're having issues, so the first thing is if you need to, you can use the lab, that virtual machine. I'm going to bring this back here. When you receive the email after you register or activated your lab, and you click on that link, confirming that your lab is ready, you will see a screen here. Actually, this is like these two screens, I think, are together like this, something like this. And if you cannot work on your own laptop or desktop because of some security or some limitations, you can activate the virtual machine and then remote desktop into it. Or do like I did, which is just open a new browser on my laptop and navigate to portal.azure.com. Once you'll get the channel screen to authenticate. And what you want to use is you want to use the username and password that's provided in the environment details. So essentially, again, if you go to that link, you will see under environment details that username and password that it's just for you under this tab. So with that, you log into the portal. And if you don't see anything here, you would just go to resource groups and click on the Synapse AID workgroup. Once you open that resource group, you will be able to first of all initiate or resume the SQL pool. So that's an important step. Make sure you resume it. And then you can go back to the resource group and open your workspace. And that workspace will show you the link to open your Synapse Studio right here. So once you do that, you should see this environment. And right now we are following lab number 1. I believe that's where we're at right now. And we are we're going to the notebook section of the lab. I think the third exercise within that first lab. So I hope that answers that question. Let's see, hey, open the following steps, select the exercise 1, error, press run, I get failed, run parse, incorrect syntax. Okay, so yeah, so make sure that hopefully this is not the case, but the environment should be created correctly. But to replicate what we're doing right now, is you're gonna go to your linked tab, open up your data lake, primary data lake store, navigate to your worldwide importers folder, navigate to Parquet 2012, Q1, invoice date key, January 1st, 2012. Right click on a new notebook, load to data frame. And a very important step is to make sure that you have selected the Spark pool assigned to you. In this case, mine is called Spark Pool 1. Probably yours is the same. And make sure that the language selected is PySpark, Python. Once you do that, you should be able to click Control Enter and run that cell. So hopefully that answers that question or helps you with that issue. All right. So in this case, once we run the cell and the session starts, it will read the data from that Parquet file and load it into this data frame called DF, right? DF data frame, and only show the first 10 records. As you can see, the first time it took a little while, and if you run it again, now because the session is started already, it doesn't have to wait for that, and because you already read that file, it knows how to read it quicker, and it's able to display that in about 2 seconds, right? Now, here we're only limited to 10 records. What if we want to increase that? So what we can do is we can add a new cell. If you look at the button or icon right here, if you click on that and select code cell, what we can do is we can copy this same command or type it. So it's essentially display, and you see the IntelliSense, right? Display. In this case, we want the DF data frame. And instead of limiting it to 10, let's limit it to 100, right? And then we're going to Control Enter. And what's going to do is it knows that it can read the DF data from this section. So the DF data frame is loaded into memory. And now we're going to display the top 100 records. You can see how fast it is, right? It really doesn't take a long time to read more data because it's already essentially in memory. All right. Now, in addition to that, like I mentioned, you can visualize the data not just in a table grid. You can also visualize it in a chart. And what I'm going to do is I'm going to collapse this section so I get a little bit more real estate. And in here, you can see that by default, it selects whatever values and columns it thinks are the best for visualizing, but we can tweak that chart by clicking on this button on the upper right section. And this will bring up the properties of that chart. So we can select a different chart if you want. We're going to keep it for now as a bar chart. In the key, we're going to select, instead of the sale key, we're going to select the customer key. should be here, customer key. Then under values would be the city key. And then the aggregation will be a count, right? A count of cities by customer. And then we click the apply button. And now we see, a little bit better view of our data. So this is all built in within Azure Synapse, the ability to quickly read data, quickly visualize data within the Azure Synapse to do some initial discovery and analysis of the data. All right. All right. Let's see. Now in the instructions, it seems like they changed the user interface. So if you want to hide this result set, you can click on the you can click on here and then hide output. Then that collapses that cell. In instructions, it's pointing you to icons that I guess they just changed recently, because it also changed on my end, which was different before. All right. Yeah, so you see that the instructions here are different. So before you had this big button called add code, add text, and you had these buttons here to do some action. So now instead, they just changed the UI. Instead, you have to go through here and click on this button or icon to create new cells. All right. So we're gonna do the same. Again, you can read from either Parquet, you can read from CSV, and be able to analyze the data, visualize the data really quick. So now we're gonna jump to the next exercise. So if in your lab, you can click next, and that will take you to exercise 2, which is build a modern data house with Azure Synapse Pipeline. And we can close this, and we can discard changes. All right. So in this exercise, what we're going to do is we're going to build a quick Azure Synapse pipeline. And for those of you who are familiarized with Azure Data Factory, this is essentially something similar to what you're going to find in Data Factory in terms of creating those pipelines. And we're also going to see how that interacts or works with some of the Spark type of transformations and activities. So the first thing we're going to do next is we're going to go into our develop tab, and we're going to create a new notebook. Now, instead of specifying, I'm going to close that. Instead of specifying, a specific data set that we're going to work with, we're simply going to start from scratch, right? From zero. And what we're going to do is we're going to click on Add Notebook, and we're going to have essentially a blank space. Here we can hide this section. We want to make sure we select the Spark pool, because notebooks, in this case, we're going to run Spark, PySpark type of, or a Scala, actually, a Scala type of commands. By default, it shows the PySpark Python, but we want to change that to use Spark Scala instead. So again, new notebook. Make sure that we attach it to the Spark pool 01, and that we are using defining this notebook as a Spark Scala type of notebook language. All right. Once we do that, the next thing will be to create a new cell. If it doesn't show up, you can click on the plus sign, and this will create a new cell to execute code. The code that we're going to execute is in the lab itself, in this text box. So we're going to highlight it, copy, and let's see if they enable right-click paste. Command palette. Seems like they have not enabled paste. So what you need to do is do Control V. Not sure why they haven't enabled paste, but you would just do Control V, which is the shortcut of V as in Victor, which is the shortcut for paste, as you know, in Windows, right? So Control V, and you'll paste that. So what we're doing here is saying, well, in this cell, we're going to import a Spark session, or we're going to create a Spark session in all the functions and functionality within the Spark session and corresponding libraries. The next thing we need to do is we need to provide the data lake name. That name essentially can be found in your environment details. So if we go back to the lab under environment details, you should see your storage account name, which is this one, this one right here. So you can click on this button, copy, and we're going to replace that section after the @ sign with the particular data lake name. Once you do that, you can click on this button here, run cell, or use the Control Enter, or you can also do Shift Enter. I think Shift Enter, let's see, they have changed some of these. Oh no, Shift Enter actually, sorry. Yeah, so Shift Enter actually, executes and adds a new cell. So sometimes I typically just use Control Enter, but Shift Enter allows you to execute and then add a new cell. So execute, and then Shift plus Enter is execute and add new cell. All right. So again, the first time you start a new session, it takes a couple of minutes. So we're going to wait for that session to initialize, and then for this to read this variable called ADLS path. So let's see if there's any additional questions. When you go to a resource group, I get only a screen saying, welcome to Azure. So if you don't see anything in your Azure portal, first thing I want to make sure is that you are signed in with your user. In this case, it's the user defining your environment details. So make sure that's the case. If you don't see anything, you said you went to resource groups, or make sure that you go to resource groups on the top, and you should see that Synapse-AIAD. Hopefully, it is just a matter of, and potentially make sure that all filters are removed, that there's no filters being applied. But you should be able to see that resource group called Synapse AID. And once you click on that, you should see the different resources and the workspace. Hope that helps. All right, so now that we have that path assigned to this variable, we're going to add a new cell if you don't have one. And in that next cell, we're going to copy this command here. So copy. And then in here, there's no paste, unfortunately, for some reason. So we're just going to Control V. And what this is going to do is it's going to read into a sales variable or RDD the content of the file contained, or the files contained in this path. In those folders under this path, and that path is essentially pointing to that variable that we created, pointing to this particular path. So essentially, it's appending to this path these folders, and it's going to read data from that path, which is CSV format, it's saying that those files have a header, or the first row is the header row, or the name of the fields, and we are saying try to infer the schema for us, meaning it will sample the values in each of those columns, and it will try to infer if it's an integer, if it, a numeric field, if it's a string, if it's a date, etc. And it's saying that that CSV has a pipe delimited separator between the different columns. So all of this to specify that we're going to load that data using these options and parameters. Then it's going to show the first 5 rows of data, and it's going to print the schema or the metadata that it inferred as we specified that option there. So again, we're going to run this cell, and we should see 5 rows of data and then the schema that was inferred. So that's gonna take a few minutes. Hopefully, let me see if there's any other questions. Link to lab notes. Where you go? Is a cluster being started at this time? So not sure of the timing of the question, but when you're running a notebook for the first time, what it's doing is starting a session on an existing cluster that's running. Now, one of the instructions that some of the steps that we have to do before we started working is we need to start the SQL pool if it's paused, and then the Spark pool SQL should automatically start if it's off, right? It has auto pause settings turned on. I think it's 30 minutes by default. Yep. And if there's no activity, no sessions, it pauses. Once you start a new session, it automatically starts up. So the Spark cluster automatically starts and restarts based on connections, while the SQL pool, you have to manually start it before you can run queries. All right, so in this case, our Spark session is up, and it was able to read 5 rows of data. As you can see, it's not that pretty. Let's see, there's some ways to make this a little bit pretty. Let's see if it works here. Because, this is Scala, yes. Hopefully, this was here as well. This is PySpark. Maybe give me an error. Yeah, this is not supported here in this Scala. In PySpark it is, but all right. So there's other ways to visualize the data better, but this is kind of the raw, a very raw visualization that you get with the Scala kernel. But you can see at a glance, the first 5 rows, the names of the headers, and somewhat some of the sample data there. So that is from this command called show 5. The next one is print schema, and this is where, like the command implies, it is printing the schema that it implied when we specified this infer schema equals true. As you can see, it identified doubles or numeric fields, integer or whole numbers, strings, and I believe there's a date. Yeah, there's a date right there. So it was able to infer the schema by sampling the rows in our data. All right, so now that we have loaded that data frame, the next step, we're gonna add a new cell, and we're gonna go into the next exercise portion, and we're gonna copy that step 9, the code from step 9, and we're gonna paste it in this cell. Now, what this is doing is it is importing certain libraries that are required to support some of these commands. And it is also assigning a variable called table name with this value. And essentially, this is the name of the table that we're going to be writing to. If you go back to data, expand data, and you go to workspace, what this is pointing to is it's saying that we're going to create a table called sale under the schema called WWI staging in the SQL Pool 01 database. If you expand SQL Pool 01 database and you go to tables, let's look for this look for this schema called WWI_staging. You see that there's no table right now called with a schema of WWI staging. And most importantly, there's no table called sale, right? So what this is doing is it's going to write into a table called sale the first 10,000 records of our sales data frame that was specified here, right? So the data, the first 10,000 records of this data frame are called sales, or a variable called sales. It's going to write it in into the table name that we specified here, right? Using these functions on the SQL Analytics connector. So if we run that, we should see that table being created under this database. Now, once it executes, it will not automatically refresh. You will have to refresh by clicking on the ellipsis and clicking on the refresh option. So we're going to wait for that to execute. And then we're going to refresh the list of tables and should be able to see that. In the meantime, let me check. I guess there's no new questions. So hopefully we were able to resolve those issues. Now, again, the first time you import new libraries, it takes time because those have to be added to the library cache. And also, first time it executes some of those functions, it takes time because it has to compile and make those functions available. So it executed successfully. And the next thing is we need to refresh this. So let's click on the table section. You see that ellipsis or actions icon. And we're going to click there and click refresh. Once we refresh, we should see that new table that was successfully created now down here, WWI staging sale. You can also expand that column, the table, to see the columns created. And as you can see, these are the exact same columns that were inferred from the file. The data type's a little bit different because different data types between different technologies, right? So this one is using floats and integers and dates, right? Instead of doubles, as explained here or shown here. But we can see that we were able to read from a file, in this case a CSV file, infer the schema, and then load the first 10,000 records into this table called staging sale. So now that we have that loaded, we can actually read from that table. And the way we do it, I did it is just click on the ellipsis, new SQL script, select top 1000. And now I can see the data and be able to query that data using SQL. If we count the number of rows, we would expect to see 10,000 records, right? There we go, 10,000 records, as we explicitly define here in our limit function. So what this shows you is that data engineers that have to, load, transform, shape the data can do so in their preferred language. In this case, they can use Scala, they can use Python, C#, or even Spark SQL to load data from files, load data from databases, load data from an API, an OData feed, make it available in a format that other information workers can then consume. In this case, data engineer make the data available in this database. And now, as a data analyst, I can come now and query that data in a SQL-like type of format. So that is very powerful because as many of you may have experienced so far or currently in your organization, data engineering team, ETL team use their own set of tools. They create copies of the data somewhere, and then another team brings the data into some type of other format, like a relational database, an analysis services, or a cube, or multidimensional cube, Power BI data set, and then information workers, business analysts, data analysts, then use Excel, Power BI, SQL Management Studio, whatever their development application is, to be able to then query the data, right? So each of these creates those silos of data, silos of applications and tools. Now with Azure Synapse, it's all in one user experience, same data sets that everybody's working on. You don't have those different silos, right? And allows a lot of this fast collaboration. All right. So then the last step here was to look at some of the performance metrics. And if you go back to this notebook, you can look at some of the performance metrics in while this is running. If this is taking long, you should see things that are going in progress. But you can quickly triage and see where the bottleneck is. It might be a poorly distributed or a not appropriate partition data set. And you can do playback and look at what happened throughout the entire flow of the data or individual steps of the data. So that's really powerful to be able to troubleshoot performance issues, right? Again, all in one environment. Data engineers don't have to go somewhere else to get this information. It's all in the same development experience. All right. Next, the next step is talking about those data pipelines, right? And this is where we're talking about data integration type of activities, very similar to what you do now in SSIS or in Azure Data Factory. And like I mentioned, as you can see, the user interface looks very similar to Azure Data Factory. So what we're going to do is we're going to close these notebooks or our scripts, and we're going to go to the integrate section. And then we're going to open the exercise 2, enrich data. Now, in this data pipeline, we have two activities. We have a data flow activity and we have a copy data activity. The copy data activity, as you can see in the description, essentially brings copies data from one storage into a staging area, right? And essentially, it's an activity that moves files from one location into another location. Then the next step is to enrich the customer data. So this is customer information, like customer name, demographics, etc. Right? And the next step is to process that data and add additional information. For example, and I believe it is they're enriching this data by adding zip code geographic information to the customer data. So this is a very common scenario or use case where you have like customer addresses that need to be standardized, make sure zip codes and cities align, make sure that city spellings are like standardized in spelling. So for example, here in Tampa, we have the city of St. Petersburg, and sometimes it's referred to as St. Pete. Sometimes it's spelled as St. Pete, sometimes as Saint, Saint. So different ways of spelling a city name, right? So this is a common scenario where we want to standardize so that we can see all of our customers in St. Petersburg under a single St. Petersburg city spelling, right? In addition to that, other use cases like getting the latitude and longitude of addresses, it's important. Now, as you can see, there's a precedence that is implied here. First, you need to bring the data into staging that then the data flow needs to read. But if the data is not there, this activity, the data flow activity, cannot start unless this activity succeeds. And this is the concept of a data pipeline. And in SSIS, if you're familiarized with SSIS, this is where you have the control flow and data flow. So think of this area as your control flow, and then we're gonna navigate into a data flow. But you can specify connectors or precedences so that this activity runs first, and upon its successful completion, then you jump into the next. The way to connect those together is by selecting from this green path into the next activity. And that creates the what's called a success precedence constraint, right? Once that this is connected, the next step is let's execute a data flow. So before we do that, let's open it. And the way you do that is just essentially double clicking, right? Or clicking on that arrow icon. And this opens the data flow. So notice that we were in this tab that is essentially the control flow. Once you click on this icon or double click on it, this opens the mapping, data flow mapping inside that activity, which is this tab right here. And what this is doing is just reading from postal codes. In this case, it's assigning postal codes, filters, I guess. Reading postal codes from another file and the list of customers from one file or one table. Filtering on specific zip codes, joining these two data sets together, selecting specific columns, and then sending that data to two paths. One is to a I believe this is a Azure Data Lake storage, so flat files, and then sending another copy of that same data to a SQL database table. In this case, it is inserting it into a table called enriched customer data. Enriched customer data. All right, so let's go back here to this tab and just click on debug. When we click debug, it's going to ask us to start a integration runtime. So behind the scenes, like I mentioned, this is similar to Azure Data Factory, which it leverages integration runtimes to execute some of these pipelines. So we're going to click on turn on debug, and it's going to start its own set of resources behind the scenes. In this case, it uses Databricks for the pipeline execution. And you can see under your resources, if you go back to your Azure resources, you will see that there's an Azure Databricks service already configured for you. And essentially what this is doing is starting up that Azure Databricks and running the pipeline. We can see a visual indicator that it already completed this activity. We can see the check mark there. And we can also, if you click on it, you see the properties of that activity. If you click on the white space, you see the pipeline properties and progress. You can see that that activity, import customer dimension, succeeded. You can see some details about it. What's happening in this case is loading from Azure Data Lake Store into a data warehouse table, and some of the statistics related to that. And then in this second step, it has not yet completed, but we can see what's happening, and what is the execution flow of that data. All right. So we're going to wait for that to complete. And then what we should see is in the let me see, in the table, which is called the rich customer data. Where is the database table? Our sync is called WLS staging customer. Okay, and if we look at that, it is inserting into the SQL pool of 1 under the WWI staging and rich customer dataset. All right. So that's probably going to take a little bit more time, but this is essentially the flow process, right? Again, everything within the Azure Synapse Studio development environment, where we already see how we can do data exploration and data transformations with SQL and Python, and then more advanced ETL integrations, data pipelines, using the integrate functionality of Synapse. All right, so let's go to the next step. So the next exercise is Power BI integration. So once we have prepared the data and created the data sets, we now want to visualize it. And as you can see in the workspace, if you go back to home, under where is it linked? Develop. Under the Develop tab, you will see, again, your SQL scripts, the notebooks, some of the data flows, in this case, this data flow that we're running here. And then you can also see the Power BI artifacts or assets. In this case, we have a Power BI workspace that has already been configured for us. If you open a new tab and go to powerbi.com and log in with those same credentials, so we click on sign in using the same lab credentials, you'll be able to log into your Power BI workspace, and particularly to a workspace that has your attendee ID in there. And right now we can see that that workspace is pretty much empty. There's nothing there. So, traditionally, there will be another team that develops data sets, reports, dashboards, and deploy contents here. And then those contents will be available in your Synapse workspace. Or you can actually develop, publish Power BI data sets and reports, dashboards right here in Synapse without having to even open Power BI desktop or go into the Power BI service. The way we do that is we're going to follow these instructions. And what we're going to do is we're going to create a new data set, right? So we're going to click on our Power BI datasets. When you click on that section or in that area, you'll see that you have the new Power BI dataset option here in the top. So you're going to click on that. If you have not installed Power BI Desktop, you can click on this link and install it. Now, this step is only necessary because we are going to create a new desktop, a new data set. The idea is that you will have some of these data sets already created and deployed, or somebody else in your team will do it. If not, we can define now, and I'll walk you through the process of doing that. So we're going to click install or start. Then we're going to click on the SQL pool 1 data source. Now, again, the idea here is you don't have to go get this connection string somewhere else. It's already built in. It already knows what are the different data sources and then data sets available right here, right? Without having to go somewhere else. So click on continue. And the next thing is what it does is it creates a Power BI dataset file that already has the connection strings configured to connect to the data source you provided and allow you to create that data set. So we're going to click on download. Once it downloads, you can open that file, and that file will open in Power BI desktop. So that's what's opening right now, the Power BI desktop. And if you have not logged in, it will ask you to log in. In this case, per the instructions, we're going to use a Microsoft account. And we're going to click the sign in button. Okay. So we're going to click that button. And it's going to ask us, what credentials should we use to connect to that data set. In this case, it will be our lab environment. Okay. So that's a previous lab environment. So let me make sure it is the correct one. Should be this username. Yep. Doesn't like that. Okay. I guess it's different. And I'm gonna grab the correct password, which I already have saved here. Just give me again. Let's see what's going on. And select the password one more time. All right, perfect. So yeah, once you provide your username and password, it will allow you to connect to that data source. In this case, you see what is the connection string it's using. You don't have to worry about that because it automatically does that for you when you define that in your steps. Then the next step is we're going to connect to a particular table under that database, in this case, the SQL pool 1, which is this same one of the databases that's there in tables, right? And we're going to click on load. Now, because this is a data source that supports direct query, it allows us to select either do we want to import the data or we want to connect using direct query. Import, like the name implies, is importing the entire data set into the Power BI store. Direct query, which we're going to select, is essentially connecting back to Azure Synapse and only retrieving the data sets that are required for the visualizations that we're going to be creating. Direct query allows you to essentially connect to very large data sets. So this is the option that we're going to choose. Direct query, well, we click OK, wait for that data to load. Direct query also allows you to connect to not only large data sets, but also be able to retrieve data in a more real-time fashion because it's connecting live to the data. So if there's any data changes, you click refresh and automatically shows up here. All right. So the next step is once we have that defined, we're going to publish this data set. So all we're doing here is defining a data set within Power BI Desktop that we're going to publish. So let's go ahead and publish here. It's going to ask us if we want to save changes. We're going to say yes. and I'm just going to put it here for now, and this is going to be called my, you know, you know, Synapse Workshop Dataset DS. All right, you can give it whatever name you want, doesn't matter. So it's going to grab that file, and now it's going to push it into your Power BI workspace that's defined. So we're going to select that workspace, not my workspace, but Power BI workspace with your attendee ID. Click select, and it's going to push that data set over into Power BI. Now, there's a additional step that we need to do. So I'm going to click got it. And if you go navigate back again to your Power BI environment and log in with the same credentials, now you should see under workspaces, that workspace that we already defined, and we should be able to see now both a dataset and a report that got created. And essentially with Power BI, when you publish a dataset, or a report, it automatically creates a report in a dataset. In this case, just an empty report connecting to a dataset. One of the things that we need to do is in the dataset section, under these more options, we need to make sure that we specify what is the connection credential that it needs to use to connect back. So I'm going to click on settings. So under the options, settings. And as you can see, the data source credentials, it gives you this, warning that the data source cannot be refreshed because credentials are invalid. And this is essentially the proxy account that you want to use to connect back to the data source. In this case, that's SQL Pool 01. So we're going to click on Edit Credentials. And here, I think it is OAuth 2 that it's wanting us to use. The OAuth 2, yeah, so it's an OAuth 2 token. And this, you can leave it blank, but I typically use organizational. And click Sign In. And what's going to do is it's going to ask for the credentials that it should encrypt and use as the proxy account. In this case, my same account. In real world production environments, you will have like a service principal that you will do that, right? Not your own personal connections. So now that that is defined, now we can proceed with the next step. And that is, we can close this. We can close this if we want. We can proceed with these steps, continue. Click close and refresh. So now under the Power BI datasets, now we can see that dataset that we created called the Synapse Workshop DS, right? Which is the same dataset that we saw on the Power BI portal. And then now, if we hover over that dataset, we should be able to see that icon that will allow us to create a new Power BI report. So we're going to click on that. And as you can see, now we are going to develop a report right here within Synapse without having to open Power BI Desktop, without having to go to the Power BI portal. All is now integrated here. What we're going to do is we're going to create a quick visualization. In this case, will be a line and clustered column chart, which is this icon right here. So we're going to click on that, and it creates a placeholder for us, so we can make it a little bit larger if we want. And we're going to select several fields from our fields section. In this case, from the data set that's being published in Power BI. And we're going to select the salesperson key as our shared axis. We're going to select profit as our line values. Then we're going to select the total excluding tax into our column values. We can close that if you want. And what this is doing is it's connecting back to that data set that's already published in Power BI and using the connection strings to be able to render that data in our report. And we can, expand this and do other things, like add slicers and do all the normal development that we can do. In this case, the exercise is asking us to do a filter and only show profit where we have a profit that is greater than 50 million, I believe. Yeah, 50 million. So 5, 0, 1, 2, 3, 1, 2, 3, and then click apply and filter. And as you can see, as we apply that filter, it's going to reduce or only show us those records or those values that are in within that filter criteria. And then the last thing is to save this report. So we're going to save it we're going to save it as, you can give it whatever name you want. In this case, I think it's just saying the key sales by person. All right. So now that that is saved, we can look at, we can close all this if we want and go back to our develop section. And under Power BI, now we can not only just see the data set we created, but now we can see that report, right? So this is, again, an all unified experience where we went from data ingestion, data transformation, doing some ETLs, to all the way to defining data sets and creating visualizations right here within Synapse, right? A couple tools that we had to use, like to publish the data set. But other than that, it is all self-contained in this unified development experience. All right. So the next couple exercises are meant to highlight some of the performance metrics, some of the monitoring. We're going to skip that for now. And then the other exercise is how do you use models within Synapse, and how do you leverage predictive analytics and even prescriptive analytics within Synapse. So I'm going to close these tabs. This is still running for some reason, so we're going to let it run a little bit more. Actually, yeah, I'm going to stop this for now. All right, and we're going to close that. So yeah, so the last step is, if you go to the develop section, you can see here there's a script for predict with model. Exercise 5, predict with model. And this is a very simple script that allows you to understand how can you leverage existing machine learning models, AI models, predictive models, and bring them into a certain type of analysis. Now, this is the lab, the exercise that I mentioned earlier that has some issues that has to do with different versions of the lab and data sets and model structures. But hopefully this will be fixed in the near future. And I'll give you some resources where you can go experiment with some other examples that Microsoft provides. But the bottom line here is that the process to follow is to read models that are stored in some type of data store. In this case, it's stored in an actual database table called WWI models. In other sections of this same exercise, it shows you how those models are stored in a table. And essentially, one of the requirements is that those models are stored in hexadecimal or binary format, word binary hexadecimal type of format, and that they are converted into an ONNX format. So maybe a little bit out of scope for what we're going to do here, but if you are interested in learning how all this was put together for this particular exercise, if you go to the Azure Databricks cluster, and launch the Databricks workspace. I assume this is on. I think it's on, right? Should be on. If you go under workspace, shared, you will see the exercise 5 steps that were executed to generate that model. And essentially, it's a linear regression model that tries to predict the quantity of a particular product given a particular customer. So the quantity of products by client, right? So for example, which clients are most likely to buy a mug, right, or a cup, or some type of retail item. And what it does is it looks at past information, past sales of that particular product and customers, and then it will predict how many will it buy given a customer product combination, right? And that's essentially what this model tries to do. And you can see the score, right? The prediction, the accurateness of that prediction. So it's well above 80% that this particular customer will buy that particular product and for this particular quantity of products. So that's how it's put together, and it's using again that ONNX, or I think it's referred to, or you name it. You say that, pronunciate that as Onyx, but it's ONNX, and it shows you the modules that it uses to generate that as a Onyx type of model. So that is how that model was put together. And so the last step in the exercise I want to show you is how you call that model from the stored in a var binary in a table, and then how you use the predict function, how you pass data. In this case, is passing data from a table called sample data into that model, and it's getting back a prediction for each of those customer product combinations, predicting how many products will that particular customer buy, right? So that is essentially as easy as it gets, right? The model might already be built for you by a data scientist, stored in some model repository, either in Azure ML. It could be in a database stored as a Onyx model. And then the only thing you need to do is know what fields you need to map or pass to the model, and then get the prediction, in this case, using a predict function and passing those different options into the function. And then once you get that prediction, it will insert that into a table, or you can just visualize it and export it to Excel, for example, if you want to, or send that information over in some other format. But that is essentially the scope of the workshop today. So I want to thank you again for attending, and feel free to ask any questions in the chat. I think I'm going to be available for another 10-15 minutes or so if you need some particular quick questions that you want answered. Or you can also reach out to me via a Calendly. So the link is there to schedule some time with me and be able to have one-on-one discuss any challenges, any questions you may have. Okay, so I'm following on, but my database got paused. Okay, so if you have, for some reason, your database, your SQL pool got paused, what you need to do is, if you go back to your Azure portal and go back to your resource group called Synapse Analytics, you will see this SQL pool 1. Click on that, and then, Where'd he go? Synapse group. Oh, you know what happened? The lab got wow. So this is a very time limited environment that Microsoft makes available, and it seems like they already took it down. I will have to have a conversation with them to allow us to complete the workshop within the time that we schedule, which is supposed to be until 3 p.m. Eastern time. It's still 2:54, so I'm not sure why that is the case. All right, but the good news is that right after this lab, or after this workshop, either today, later on, or tomorrow, like I mentioned, you will get an email from either us as AgileThought or from Cloud Labs. Actually, the email address is noreply@cloudlabs.com. And in that email, it will give you instructions how to activate another environment similar to the one you just had access to, and be able to run the same labs on the same data sets at your in your own time. It is good for 7 days, so be on the lookout for that email between today and tomorrow, because you have 7 days from that email to activate the lab. And then once you activate the environment, you will have 6 hours to be able to run through all these exercises, and also, potentially bring your own data and experiment with that data. Just keep in mind that that environment will be shut down after those 6 hours. So, it's not a production environment, and it's not a production in an environment that will last beyond that time frame. So, yeah. Other than that, what I would say is, in addition to the lab resources that I just mentioned, if you haven't done so, sign up for an Azure. Let's see. I want to open in incognito. Yeah. So go to portal.azure, and one of the to create one. Click on the create one if you haven't done so. You can create a new account. When you create a new account within Azure, actually, that's not where I wanted to show you. Go to azure.com, I believe. Yeah. So this is the link, actually. If you go to azure.com and you click on that, try Azure for free, it will give you 12 months of free services and $200 of credits to explore Azure for 30 days. So if you are trying to prove and learn more about Synapse and some of the other technologies, you can sign up for these free credits in a free account, and then instantiate a Synapse Analytics workspace. And once you have that, if you go to Azure Synapse, in the Azure Synapse page, you will see the customer stories that I talked to you about. So some of the ones I talked to you about, and some of the ones, additional ones. You will also see getting started, and you can look at the Knowledge Center and be able to see all of the and quick starts that you'll be able to start working with. You see here the Knowledge Center. Though you start working with some data sets that are available for free, and step-by-step, essentially, guidance on how to create a analysis in Azure Synapse with some of those demos. So that is all I have for now. So again, feel free to schedule some time with me. And 30 minutes. Help you with your journey, and understand what challenges you may have, that maybe we can provide some guidance and help you with the adoption of Azure Synapse. So with that said, thank you very much, and I hope to talk to you sometime soon. So thanks for attending today.